You hold your breath, you press the power button, and your screen springs back to life. You just spent hours repairing a stubborn glitch, and now it is finally fixed. In that moment of triumph, it is easy to assume the machine is now invincible. Hello everyone, I am Sir Suleman Mehmood. Think about fixing a flat tire on your favorite bicycle. You patch the rubber perfectly, but what happens if you immediately ride that bike through a patch of thorns and leave it out in the pouring rain? That tire is going to fail again, almost instantly. Treating a computer is exactly like going to the dentist. When a dentist fills a cavity, they solve the immediate crisis, but you do not stop brushing your teeth forever. Dental health, just like digital health, is an ongoing daily requirement, not a one-time surgical event. A computer is a complex, highly dynamic system. The hard truth is that the exact second you finish repairing it, the process of decay begins all over again. This brings us to a crucial practice: post-troubleshooting maintenance. These are the mandatory, deliberate actions you must take to stabilize a system long after the initial fix is applied. Let's test this concept. Imagine your computer is running incredibly slow because the storage drive is completely full. You delete one large old movie to free up some space today. What do you think happens next week when you download 5 new video files? The drive simply chokes again. Addressing a symptom, like deleting a single file, without changing your ongoing maintenance habits, guarantees that the exact same problem will rapidly return. This animated diagram of a hard drive shows us the first stage of neglect: software suffocation. Over time, temporary files and hidden background apps accumulate, shown here as red blocks. They build up like plaque along the drive, and as you can see on the adjacent graph, the processing speed responds by entering a slow, steady decline. Eventually, those junk files spill over their boundaries. The direct consequence is severe performance degradation. The processing speed flatlines to 0, and your entire system freezes. Stage 2 is system failure. Operating systems rely on constant updates to patch vulnerabilities in their code. When you ignore those updates, the core software foundation destabilizes. Applications refuse to open, and the computer begins to crash spontaneously. This instability creates Stage 3, security collapse. Without regular updates and routine backups, those unpatched vulnerabilities become wide-open gateways for viruses and malware to exploit. These software failures are completely invisible as they accumulate, but they converge on a devastating outcome. Left unchecked, a lack of maintenance can cause your irreplaceable personal data, even your photos, your digital documents, your life's work, to vanish permanently. But digital decay does not stop at software. Inside the physical chassis of your machine, the environment is quietly turning hostile. Dust particles are pulled in, aggressively clogging the cooling fans. This leads to Stage 4, hardware death. With the airflow blocked, the computer cannot vent its internal heat. The thermal limits are quickly breached, causing the fragile silicon components inside to literally melt and destroy themselves. Think about the last time an app suddenly crashed on your phone or PC. What was happening right before the screen went black? Was the back of the device burning hot against your hand? Were there 20 different applications silently running in the background? That intense heat was a symptom of a larger systemic problem. By ignoring post-troubleshooting maintenance, a minor, easily fixable software glitch escalates into permanent, expensive hardware destruction. Fortunately, we have a built-in solution to stop this cycle. It is called system health monitoring. Think of a car's dashboard. When a check engine light illuminates, it warns you of a mechanical issue long before the engine actually stalls on the highway. Your computer has a very similar dashboard. Operating systems use internal sensors to track 3 specific metrics: RAM in use, CPU load, and thermal temperature. These act as an early warning radar. If a fan clogs, the temperature gauge spikes aggressively, giving you time to shut down before physical melting occurs. System health monitoring effectively breaks the cycle of decay by taking invisible internal threats and making them visible to you while you still have time to fix them. Achieving true digital longevity requires a complete shift in our mindset. We have to move away from a reactive stance, where we only troubleshoot when things are broken, and embrace a proactive stance, where we actively maintain the machine's health. It is the daily combination of regular cleanups, routine updates, and active system monitoring that keeps a computer running swiftly and safely. In our next lecture, we will dive directly into your operating system to explore exactly which built-in tools you can use to monitor these critical health signs. Repairing a failure is a vital skill, but true technical mastery is found in the quiet discipline of keeping a machine alive indefinitely. Keep exploring, keep questioning, and I will see you in the next lecture.